All right, so the first video of chapter 4 is talking about matter. What is matter? The formal definition for matter is it occupies space and has mass. So basically, if you can feel it, touch it, and see it, it's matter. So things like a pencil, your skirt, the desk. People often mistake air as being something that isn't matter because they feel like they can't see it, so it must not be matter, but you need to make a note somewhere that air in fact is matter because it's made of elements. Elements have mass and they occupy space, okay? Some examples of things that are not matter, which you're going to want to write down, are things like light and heat and sound. Okay, now, matter comes in 3 physical states: solid, liquid, and gas. Your chapter handout has a table. It's table 3.1 that outlines all of the properties of the 3 states of matter. You're going to want to know that. You're going to want to know that solids have particles that are touching each other and they're packed extremely tightly. I couldn't compress a solid any more than it already is. Solids have definite shape and definite volume. And if it comes to movement, the particles in a solid will vibrate in place or they will oscillate in place. Now, if we go on to liquids, the particles in a liquid are a little bit further apart from each other. They have the ability to slide over each other, and this is how water flows out of a faucet. Liquids have definite volume, but they have indefinite shape because they take on the shape of their container. In terms of compressibility, in the table, in your chapter handout, right here where it says that they are incompressible, I want you to change it to slightly compressible. Because since the particles in a liquid have a little bit of space between each other, you could slightly compress them, okay? In terms of gases, gas particles are really far apart. They only touch if they collide with each other, and they have indefinite shape and indefinite volume because they take on the shape of whatever container they're in, and they take on the volume of whatever container they're in, no matter how small that container is or how large that container is. Gases are really compressible because there is so much space in between the particles themselves. Make sure you know that diffusion is a property of gases. That's where gas particles move from a concentration that's really, really high to a concentration that's lower. So this is what the smell of a pizza is going to do. So if I bring a pizza into the classroom, then what's going to happen is the pizza smell is going to end up moving from the box to the entire classroom. And that's an example of diffusion. Okay? Now, what I would do is I would pause the video, take a look at student exercise number 1, fill in your responses, and then check it with the answers here. So student exercise number 1 says, identify the physical state and describe the arrangement of particles in the following substances at room temperature. A, hydrogen. Hydrogen is a gas. At room temperature, the particles are really, really far apart. B, water is a liquid at room temperature. The particles are touching a little bit, but there is a little bit of space in between them. C, candle wax is a solid at room temperature. The particles are touching, they are close and compact. D, alcohol. That's a liquid at room temperature, and the particles are touching, but there is a little bit of space in between them. Okay, now, in terms of describing the processes that take place when I move from a solid, which I'm going to abbreviate with an S, to a liquid, which I'm going to abbreviate with an L, to a gas, which I'm going to abbreviate with a G. If I convert a solid to a liquid, that means I'm going to melt it, okay? If I convert a liquid to a gas, that means I'm going to vaporize it. If I'm going to convert a gas back to a liquid, that is condensing it. And if I convert a liquid back to a solid, that is freezing, okay? 2 other terms that we don't use that often, but you still need to be familiar with, are converting a solid to a gas, which is sublimation. This is what solid carbon dioxide does this at room temperature. Solid carbon dioxide is also known as dry ice. Mothballs also sublime at room temperature, okay? If I'm converting a gas back to a solid, that is known as deposition. Make sure you know every single one of these terms, okay? And know the description for each process, which I've just given you. Okay, I would stop the video here and take a look at student exercise number 2, fill in your responses, and then check them with mine in the video. So student exercise number 2 says, what term applies to each of the following changes of physical state? A refrigerator changes a gas to a liquid. Okay, a gas to a liquid is known as condensing. B, orange juice changes from a liquid to a solid. So a liquid to a solid would be freezing. C, iodine vapor changes from a gas to a solid. So if I convert a gas to a solid and I completely bypass the liquid phase, that is known as deposition.